Hello everyone, dear master's scholars, PhD candidates, and researchers. My name is Rustamov Odilbek. I'm from Tashkent State University of Economics, Faculty of Management. Today I'm going to teach you how to work with Stata software that's often used for data analysis and visualization. So let's get started. First thing we will do is search for World Bank Open Data. Here is its official website. We enter it. As you can see here, there are two ways of searching. First one is for by country, second one is by indicator. I'm doing research about the country, and my country is Qatar, so I will choose the first one. Yes. From here you will find your own country. And now we'll download all the information in Excel file. We will choose Excel here. Now it's transferred to our Excel file. From here, we change it to data. Yes, now it's ready for work. Next step is we will open new page, sheets, yes, and transfer information that we are going to work with to the new page. So firstly, we will transfer this one, country name, its years, all the years, here you can see, so it's important. We should place it vertically because it will be more easier to work with. And now we will choose one dependent and 5 or 6 independent variables to work with. It's up to you, it's your own choice. For example, we can choose labor force, total labor force of Qatar, and we will be transferring all the information like this to the new page. You can also take, there are many variants, you can choose any of them. We can also can choose GDP per capita, that's also important one. So copy and then transfer. There it is. And also manufacturing, maybe here it is. Manufacturing value added to annual gross. It is. Now it's all ready. Now here we have some unnecessary information that we should delete. For example, this one, the first row, it's not important. We're not working with it. And the second one also. But it will stand indicator name, labor force, GDP per capita. But the next one isn't also important. So we delete it. So we will shorten their name to make it easier for us to work with, like this. Just manufacturing. Yes. It's all the information from 1960 till the 2023. Here it is. So that's how you transfer information from World Bank open data to Excel file. Next step is working with Stata. Next step is the most important one, working with Stata. We will import our Excel spreadsheet to Stata. You should do it like the way I'm showing you. Here it is. And we will choose import first row as variable names. Yes. Here it is. Our variables. I choose one dependent variable and 7 independent variables. These are GDP per capita, population, manufacturing, import and export of goods, agriculture, and unemployment. We will type rows. Here you can see our first variable years is in red. What does it mean is Stata is not reading this information, is not working with it. So we should encode it. And it's quite easy. We just type encode, choose our variable, generate, and choose a new name for our variable. I just changed it to year. Here it is. Now there are two variables with different name, but with the same information. We will only need the second one. So we should remove the first one. How we can do it is, right, type drop and choose years. It is, it's removed. It's removed. Now we should move the years to the first row. We will type move, choose year and GDP per capita. Now they will change their places and now year is in the first row and it's ready. Let's see. Yes, now it's in blue. That means it's good. So the next step is transfer our do file to Stata. I already prepared my do file. Here it is. These are all the codes that we are today working with. So the first one is ssc install as doc. Copy and paste. For this we will wait a little bit. Yes, it's already installed. Now the next one is as doc sum. See. Here it is. I will be putting all the information to my research, to my word interpretation. So, like this, and place it to here. And now the explanation is this table presents summary statistics for various economic and demographic variables from 1960 to 2023, including number of observations, mean standard deviations, minimum and maximum values. So next one is, we don't need this, it's a line. It's not that important. What's important is two-way line. So we move to Stata again and write. We forgot one code that's set year. If it don't do it, Stata will not work. Here it is. Now we can write it. It was here, two-way line manufacturing. It will show us the graphs. Manufacturing. Second one is agriculture. Here it is. Third one is GDP per capita. Here it is. And then population. I did only 4 variables because I had a limited time. And we will write graph combine. Yes, it will combine all 4 of graphs. So I will put it to my research. Yes. Here. So the image presents time series graphs of Qatar's key economic indicators, including GDP per capita, manufacturing, agriculture, population, import and export of goods, and unemployment. Yes. So let's move to do file, and the next code is scatter. It also shows us graphs, but in different way here. Manufacturing and exports. We will do the same, copy and paste. GDP per capita and manufacturing. Third one is manufacturing in here. Here it is. And the last one, agriculture and year. This is the fourth graph. Yes. And now we type the same thing, graph combine. And now it shows all 4 graphs in one photo. Here it is. It's easier for us than work with all the graphs separately. I will also put this to my word interpretation. Here it is. So this scatter plots visualize relationships between 2 variables and trend lines, help interpret patterns. The scatter plots the image illustrate relationships between Qatar's key economic indicators. So let's move to another coding. And this is two-way scatter. We will copy and paste. Here it is. Manufacturing in a two-way scatter. We will do the same thing for all of them. Here it is, our second graph. And GDP per capita. Our third graph. And manufacturing in years. The last one. Here it is. It's years. Here it's years. And here it's manufacturing. And we do the same as we're doing graph combine. We will combine all the 4 graphs in one photo. Here it is. Here you can see there is no enough space. So how we can change it is we will choose this and this. Here we will change horizontal to vertical. Here it is. We also do every one of them. So there will not be any problem with the photo. Yes, it's ready. Here it is. Take screen, then place it to word interpretation. So this image presents two-way scatter plots with fitted lines to visualize the relationship between Qatar's key economic variables. Now we finished the graphs. So you will go to the Pearson pairwise correlation. Next code, different. Here it is. Pearson pairwise correlation code. We will also take a screen photo of it to place it in word interpretation. And correlation tests determine the strengths and direction of relationships between economic indicators. The table presents pairwise correlation coefficients between the key economic indicators, showing the strengths and significance of their relationships. The next code is Spearman. As you can see, I'm doing it only with 4 variables, which are manufacturing, year, exports, and GDP per capita. You can do it with 5 or 6, 7 variables. It's up to you. Here it is. Number of observations is 23. The same. Copy and paste. The Spearman test check if data follows a normal distribution, which is important for regression validity, and some variables may not be normally distributed, indicating the need for transformations like logarithmic scaling. And this table presents Spearman's rank correlation coefficients for key economic indicators, showing the strengths and direction of their monotonic relationships. Let's move. And there's p-norm code. Do file, and we will again came back to graphs. Here it is. Copy and paste. But it's different. Here you can see GDP per capita, and we will do only 4 graphs just to show you as an example. Here it is for manufacturing. For export of goods and for year. Here it is for year. It's very beautiful. And then graph combine. So all of them shown in one photo. I'll copy it and put to my research. Here it is. Quick explanation. The p-norm plots compare the empirical distribution of the data with theoretical normal distribution. If the data points closely to 45-degree reference line, it indicates normality. As you can see, it's all in all graphs, it's quite normal. Now, the next step, it's histogram. We will copy, move to Stata, and paste. Here it is. Every code that I'm writing is already prepared. So I'm just copying and pasting it to teach you how it looks. So export of goods, this is. Third one is for manufacturing. It is the fourth one. Here it is, GDP per capita. And we also do graph combine for this. For graph in one photo, yes. Put it to our word interpretation. And a histogram and density plot provide insights into the distribution of numerical variables. Histogram displays the frequency distribution of data, showing how values are spread across bins. It helps identify skewness, outliers, and concentrations of values. Density plot, a smoothed version of the histogram that estimates the probability distribution of a variable. It highlights peaks, multimodal distributions, and overall shape trends. So let's move to the next one. Our next code is graphbox. Yes, graphbox, copy and paste. Here it is, graphbox for years. Graphbox for experts, with experts. Graphbox for manufacturing and graphbox for graphbox for GDP per capita. Here it is, you can see. Now we also combine four of them in one photo. Here it is. Take a photo of them and place it to our word interpretation. Yes, here it is. A box plot provides a visual summary of data distribution, highlighting central tendency, variability, and potential outliers. So next one is very one of the important ones. It's called Wilk code. Here, here it is. Shapiro will we will copy it. So here it is. The Shapiro-Wilk test checks whether a data set follows a normal distribution by comparing the actual data distribution to an ideal normal curve. So our distribution was also normal. Come back to do file and next code is sdoc reg. Here it is, sdoc reg manufacturing, year, exports, and GDP per capita. We will also copy this and put to our word interpretation. Here it is. So the cron batch alpha test measures the internal consistency or reliability of a set of related items in survey or test. It assesses whether multiple items consistently measure the same concept. So here it's regression. Like here it is. There's also file. Here it is. It's a regression as a regression. Replace it to here it is. Regression analysis examines the relationship between a dependent variable and one or more independent variables. It helps identify trends, make predictions, and determine the strength and direction of relationships. So now moving to the next one. This is alpha manufacturing. Alpha. Here it is. Alpha for four variables. Place it to our this is a robust regression. A robust regression is used when data violates standard regression assumptions such as outliers and non-normal errors. So next one. Next one is a staff width. A staff width, it's showing 8.28 and it's quite good. It should be under the 10. So that's good. We will also place it to our uh, multicollinearity checks whether independent variables in a regression model are highly correlated, which can distort coefficient estimates and reduce model reliability. It analyzed it using variance, inflation, factor, correlation matrices, and condition numbers. So moving to the next ones. It's predict. Let's see. Predict. Mhm. These are just codes to make our work easier. Here it is, our graph. So we will place it to our fourth interpretation. Oh no, there's no need for it. Here it is. And graph box. Graph box y hat. Here it is, copy and paste. Here as you can see, linear prediction of our variables. We also place it to here. So next one is Shapiro-Wilk test. It's here. Yes. Good and paste. Here it is. It is normally distributed. We can easily place it to our word interpretation. Yes. Let's move to the next one. Copy and paste. Regression of manufacturing year export and GDP per capita. And predict. Predict, yes, it's predicted. We go to the file again and write our codes. Here it is. It's also E hat density. Choose it and place it to our board interpretation. To here. Yes. Now these are getting serious, so next code is RFE floats. Here it is. Here is it. So it creates a residual and fitted plot. Here is residual and fitted values, which is useful for diagnosing regression assumptions. So what does it do is it plots residuals on y-axis. Plots fitted values on the x-axis and helps check for heteroscedasticity or non-linearity. Now it's time for a game for graphs. Here it is. We should be writing it, so we should also copy and paste it to our word interpretation. So what we should do is place it, and then from here we will write the name like this graphs. like this, name, G1 and G2. So name, and then this, graph 1, graph place. Yes, here it is. Oh, it's not balancing. Uh, it's not impossible. It's impossible for us. So we just put the codes and see the graphs. Here it is. Next one, experts and in linear prediction. Years in linear prediction, manufacturing and GDP per capita. Here it is. You can see both of them in one graph. Now it's E hat. We've been doing Y hat. Now it's E hat. Here it is. Graph to Y, wage schedule. Manufacturing, like this. And the last one. Here it is. GDP per capita and manufacturing. So Stata has that last code for this. Here it is. It's showing norm. The variable is manufacturing. We will paste it. Here it is. Oh, I did the wrong thing. Oh, we should paste it to here. Yes, it's ready. So we will generate ln codes. Here it is. Ln manufacturing. We are doing logarithm to work with them later. So don't miss any of them. Be careful. Here it is. It's already defined, yes. So here it's um, it's already ready, but here you can see we forgot one of our how can I say, one of our variables. It's experts, expert of goods. So you can easily put it like this, change it, and manufacturing to experts like this. Now we can move to the next one. Generate ln here. We have done it, and then histogram. It also shows us graphs like this. Manufacturing frequency normal. This expert. And last one. Here it is, yes, it's ready. Now these are the latest codes. So Swilk, here it is, and regression, manufacturing goods. Alpha manufacturing. So it's all good. And regression, manufacturing. Here it is. So again, regression or our four variables and regression and robust. Here it is. And alpha manufacturing, we use alpha code for all of our variables. So now it's time for the end. Here it is. It estimates store log lin and estimates table. Oh, we write the one code word twice, so we change it. Like this. Yes. Now we can finish this coding. Here it is, our last result of coding. So now we can easily place it here. So I already prepared my do file and how you can log file. Do log file. It's quite easy. You can just put this and then create a name for your log file. For example, your country is US. You will write US log file and put save. Here it is. It's started. It shows time, everything. And now you will rewrite all the codes that you have written above. And it will be saved as a log file. And how you can it's quite easy to do, not that problematic. Everyone can do it. And when you finish it, you just choose close log file and okay, here it is, it's closed. So that's all. That it was all the work that should have been done in Stata. So goodbye. Goodbye.